Hi everyone. In this video, we're going to be doing A-Level Maths 9709, Paper 12, February, March 2026. This paper is 1 hour 50 minutes long, so we'll try to finish within that time limit. And without further ado, let's get started. Okay, so for the first question, they are given this equation of a curve, y equals to x cubed minus 3x squared plus 9, and we are told to find the coordinates, so the x and y values of the stationary points of the curve, and to determine their nature. Okay, so whenever you see the word stationary points, you should immediately think of dy dx equals to 0. So that's what we're going to be doing first, finding dy dx. So to find dy dx, let's write down our equation first. So x cubed minus 3x squared plus 9. And now we differentiate it with respect to x. So to differentiate a term like this, we differentiate each of these terms separately while keeping the signs. So let's differentiate x cubed first. So to do that, just bring down the power. So you get 3 times x and minus 1 from the current power. So this just becomes 3x squared. Keep the minus sign. Do the same for 3x squared. Bring down the 2. So 3 times 2, that's 6, and minus 1 from 2. So you just get minus 6x. And keep the plus sign. And to differentiate 9, since it's a constant, you get nothing. So you just get 0. So our dy dx is just 3x squared minus 6x. And now we will equate it to 0 and solve for x, which will give us our x coordinates for the stationary points. Okay, so here we can see that we have a quadratic equation. So we'll try to look for any common factors to factor out. So we can see that x is a common factor. And since both of the coefficients are multiples of 3, we can factor the 3 out as well. So we're going to factor out 3x. So factoring out 3x, you would get x minus 2 equals to 0. And now you equate both of the factors with 0 and you solve for x. So 3x equals to 0, you get x equals to 0, and x minus 2, you will get x is equals to 2. So these are our x coordinates. However, they ask for coordinates, so we also need to find the y coordinates as well. And just, sub these x values back into the original equation. So y is equals to x cubed, so 0 cubed, minus 3x squared, so minus 3 times 0 squared, plus 9. That would basically give you 9. So this is the y coordinate for x equals to 0. Do the same for x equals to 2. So 2 cubed minus 3 times 2 squared plus 9. So this is 8. This is 12. So 8 minus 12, that is minus 4. Minus 4 plus 9, that is 5. So 5 is the y coordinate for x equals to 2. So yeah, we found the coordinates of the stationary point, which is the first one is 0, 9, and the second one is 2, 5. So the first part of the question is done. Now we're going to determine the nature. Okay, so to determine the nature, the most common method is to find the second derivative. So you just find your d square y over dx squared. You get that by differentiating your dy dx, and then you substitute the x coordinate of the stationary point. And if you get less than 0, you get a minimum point. Wait, no, sorry, you get a maximum point, and more than 0, you get a minimum point. So this is all you have to know for determining the nature. Okay. So let's begin. So let's find our y squared over dx squared, the second derivative. So we differentiate this expression here with respect to x, of course. So 3x squared minus 6x. So differentiating this, you bring the 2 forward. So 3 times 2, that's 6. Minus 1 from 2. So you just get 6x. And then keep the sign and differentiate this. So you differentiate x. You bring the 1 to the front. So 6 times 1 is 6. And then you minus 1 from the power. So 1 minus 1, that is 0. So you're just removing x when you're differentiating a linear term like this. So yeah, this is our final expression for d squared y over dx squared. So now we're just going to substitute the x coordinate of the stationary point. So let's substitute x equals to 0 first. Okay, so d squared y over dx squared. So 6x minus 6, so 6 times 0 minus 6, you get minus 6. And this is obviously less than 0. So therefore, we can say that the point 0, 9 is a maximum point. Now let's do the same for x equals to 2. So you get 6 times 2 minus 6. So this is just 12 minus 6, which is positive 6. And this is more than 0. So we can clearly say that the point 2, 5 is a minimum point. And for one last time, let's see if we are following all the instructions. Yep, we have determined the nature, found the coordinates of the stationary points. So I believe we can stop here for this question. So this is all that we need to do for this. Let's move on to the next question. Okay, so for this question, we are given a diagram which shows the triangle ABC. So you can see there's a triangle with AB equals 12 cm. So this is AB. Oh, yeah, this AB, AC 9 cm. And angle CAB is 0.8. So it's all given in the diagram. An arc with center A. So this is the center of this arc. And radius 9 centimeters. So AC is the radius as well as until here is drawn inside the triangle as shown. Okay. So the shaded region is bounded by this arc, the line segment BC. So this one, and part of the line segment AB. So yeah, this. So if you still can't see it, yeah, this is the shaded region that they're talking about. Okay, so a very simple question. This one. Okay, so first part, we're told to find the perimeter of the shaded region, and our answer should be given correct to 3 significant figures. Okay, so to find the perimeter of this, let's see what lengths. So perimeter is just the total length of all the sides that makes up this shaded region. So it's basically this arc here, this line segment of AB, as well as the whole line segment BC. Okay, so let's find the length of the arc first, okay? So to find the length of the arc, you just use the formula S equals to R theta. Theta is the angle of the arc. It must be in radians for it to work. And this formula, if you forget it, it's also given in your MF19. So don't worry, okay? All right, so just multiply the radius, which is 9, times the angle, 0.8. You will get 7.2 centimeters for the arc length. And now let's try to find this length. Honestly, that's the simplest. It's just 12 minus this segment, which is the radius of the arc. So it's just 12 minus 9. So it's 3 centimeters. And finally, we are going to find BC. So to find BC, you need to, so for BC, since we have an angle and two known sides, we can use cosine rule to find BC. And unfortunately for us, cosine rule isn't given in the formula sheet. So I'm just going to quickly write it down here. It's just a squared equals to b squared plus c squared minus 2bc cosine big A. So an important thing to note about this formula for the cosine rule is that the side A and the angle big A, they have to be facing opposite to each other. Okay, so this angle CAB, you can call it big A. So the side A, small a, has to be BC. And for B and C, you can assign whichever side you like. Okay. All right, so let's start. So as we said, we're going to let A be side BC, segment BC. So BC squared equals to B squared. So B squared, I'm just going to let AC, let it be. Let AC be this side B. So 9 squared plus AB, which is 12 squared, minus 2BC. So 2 times 9 times 12 cosine angle A, which is just 0.8. Or if you just want to find the answer directly, just square root this whole thing and type it into your calculator. 9 squared plus 12 squared minus 2 times 9 times 12 times cosine 0.8. And before you press the get the answer, make sure your calculator is in radian mode. Okay, and then you square root it, and final answer you would get 8.632. Okay, so a good habit to develop is that, like, when you get an answer that is like infinite, like irrational in your calculator, you should always round it off to like more places than the given number of SF that you have to express your final answer in. So in this case, we need to express the final answer in 3 significant figures, but this is our intermediate answer, so we have to record it to a higher number of significant figures, like 4 or 5, okay? So here I expressed it in 4 SF. So just keep that in mind. Otherwise, you would like go run into this thing called the rounding error, okay? So yeah, enough talking. Let's just find the perimeter. Yeah, just add up all the sides. So the arc length 7.2, the small segment of AB 3 centimeters, and the side BC 8.632. Okay, so type it into a calculator. And you would get 18. And you would get 18. Wait, sorry, give me a while. Okay, you would get 18.8 centimeters to 3SF as your final answer. So with that, let's head on to the next part. Okay, so for the last part, we are now told to find the area of the shaded region. And again, we need to give our answer correct to three significant figures. Okay, so again, not a very difficult question, except we just have to find the area of this. So to find the area of this shaded region, you have to notice that it's just the area of this big triangle minus the area of the arc, of the sector inside the triangle. Okay, so first things first, let's find the area of the triangle. So area of triangle ABC. So one way to find the area of a triangle like this is to use the formula half AB sine C. And the condition to use this formula is that this angle C, it has to be between A and B, okay? So sides A and B, they should be surrounding angle C. And we have the perfect setup for this in the diagram given to us. So the sides AC and AB, they are surrounding the angle CAB, which is 0.8. So that's perfect. So let's use it. So half AB. So A, I'm just going to let it be 9. B is going to be 12. And C is going to be the 0.8 radian angle. So sine 0.8 radians. So I'm just going to leave the sine term alone first, since we're not at our final answer. So if you're like, dealing with non-exact terms, just leave them alone first or round them off to a higher number of significant figures than your final answer. Otherwise, you might end up with a rounding error. Or just leave them exact if you can. But in this case, we can't, so I just decided to leave it alone. So it will get 54 sine 0.8. Okay, now we're going to find the area of the sector. So to find the area of the sector, you just go to your MF19 to the very first page under a mensuration. There you can see there's the arc length of a circle formula, which we used in the previous part, as well as the area of the sector. This is the one that we have to use. So it's just half r squared theta. And again, theta, the angle has to be in radians. So let's do that. So area of sector, it's just half r squared. So r is 9. So half times 9 square theta, which is 0.8. So type it into a calculator. Half times 9 squared times 0.8. You get 32.4 cm square. And now we can finally find the area of the shaded region by subtracting these two areas. So the triangle area, 54 sine 0.8 minus 32.4. And again, when you are typing in the 0.8, make sure your calculator is in radian mode. Okay, so the final answer we get is 6.34 to three significant figures. And don't forget the units, centimeter square. So yeah, this would be our final answer for this part as well as the entire question. Let's move on to the next question. All right, so for this question, we're told that the graph of this this general quadratic equation has its vertex at 3, -5. So if you have not seen this term vertex before, it just means like a pointy edge or the pointy part of a shape or a graph. So in the context of a quadratic equation, the vertex is basically just a turning point. And the turning point could either be the minimum or the maximum point, okay? So take note that this coordinate, this point here is the turning point. And we're also told that it intersects the y-axis at these at this point at 0,31. Okay, so these are the 2 points that the graph passes through. Okay, so for the first part, we are told to find the values of all the constants a, b, and c. Okay, so first things first, obviously we are going to have to substitute all these points, all the coordinates that we see here into the generic equation. So we're going to first substitute x equals to 3 and y equals -5 first. Okay, by the first point. So ax squared, so a times 3 squared, that is 9a plus bx, so 3b plus c equals to 0. I mean, not 0, -5. So this is our first equation. And we're going to do the same for the second set. So we're going to substitute x equals to 0 and y equals to 31. So this is probably the easiest. You just substitute x equals to 0. Your a and b would be gone. You'll just be left with c. C is equals to 31. So this is equation 2. Yeah, so we found the value of c. Okay, this is the value of c. C equals to 31. So we're going to substitute c equals to 31 into the first equation. So you get 9a plus 3b plus 31 equals to -5. 9a plus 3b equals to -5 minus 31, which is -36. We can simplify this further, since if you realize that all the coefficients, they're actually multiples of 3. So we're just going to divide 3 on both sides. You'll get 3a plus b equals to -12. And to make it even simpler, we're going to make b the subjects. It's just going to be b equals to -12 minus 3a. So this is our second equation. Okay, now it's time for us to make our third equation. Okay, so in order to do that, let's look at this part, the vertex part. Okay, so one feature of vertexes is that you can find them by completing the square. Okay, so you just have to express this in completed the square form, and then you can substitute these 2 points into there. Okay, or you can use differentiation and equate it to 0. Up to you. So I'm going to use the CTS form. Okay, I'm going to use this space here. Okay, so ax squared plus bx plus c equals to 0. So to complete the square, you make sure the coefficient of x squared is 1. So you do that by factoring out a. So you get a comma x squared plus b over ax plus c over a equals to 0. And then you and then you remove the x squared term, you just make it into an x term, and the coefficient of the x term, you just leave it alone and divide it by 2. So this is just going to be x plus b over 2a squared. And then you subtract b over 2a squared, which is b squared over 4a, b squared over 4a squared plus CA, and you equate it to 0. And now you multiply the A all over again, and you get A bracket x plus b over 2a squared plus c minus b squared over 4a equals to 0. So yeah, this is our completed the squared form in terms of a, b, and c. Okay, so to get the coordinates of the turning point, you should equate the bracket in here to 0. And then once you do that, you will get both your x and y coordinates. So let's solve for x here first. Okay, so we already know what x is. X is just 3. So we're going to substitute x equals to 3. So 3 plus b over 2a will equate it to 0. Okay, I'll multiply by 2a on both sides. So we get 6a plus b equals to 0. And yeah, and there you go. We got our third equation miraculously. So we're going to substitute equation 3 into 2. Yeah, into equation 2 into 3. So you get 6a plus negative 12 minus 3a equals to 0. So you get 3a minus 12 equals to 0. So 3a equals to 12 and a equals to 4. Okay. So this is our first answer for A. And then to get B, just substitute it back into equation 2. So minus 12 minus 3 times 4. You would get minus 24. So yeah, we got A equals to 4, B equals to negative 24, and C equals to 31 as our final answers. And yeah, with that, we can move on to the next part. Okay, so for this part, we are told that the graph, from the previous part is translated by this vector right here. And using this, we have to find the equation of the translated graph. Okay, so for translation, there's like 2 parts. So you can see this vector, there's 2 parts. So this is the x like direction, like the x translation, the direction, the translation, the x direction is the translation in the y direction. So for these 2 directions, the interpretation is very different. So for the first part, whenever you see a negative sign, it means that the graph is being shifted towards the positive side, not the negative side, even though it shows a negative number in the x component of the vector. So for x, for the x component, it's always a positive. So if they show negative 2, they're actually adding 2. They're moving it to the right, towards the positive side. However, for y, it's very straightforward. If it's positive, that means it's going up towards the positive direction. Okay, so yeah, let's start. So let's copy down our equation. So y equals to, okay, A is 4, B is negative 24, and C is 31. Okay, so now we're just going to open up the brackets for x. So like I said, if it's showing negative 2 in the x column, you add 2 to every x term. So this is just going to be x plus 2 squared minus 24 times x plus 2 plus 31. And then for 7, for the y component, you just add 7 to the whole equation. So you add 7 right here. Okay, let's also simplify this just to be safe. Okay, so you expand this, you use the a plus b square identity. So a squared is x squared plus 2ab. So 2x times 2, that's 4x, plus b squared. So 2 squared, that's 4, minus 24x minus 48. Yeah, plus 31 plus 7, that's 38. Okay. And then you expand this out. So 4x squared plus 16x plus 16 minus 24x minus 10. Then you get 4x squared minus 24 plus 16. That's minus 8x plus 6. Yeah, so this would be our final answer for this second part. Let's move on to the next question. Okay, so for this question, we are told that the function f is defined as such, and the domain for f is given as x is less than 3. So using this, we need to find the expression for f inverse x. Okay, so to find the inverse function of any given function, you replace the fx with y, and you make x the subject of the equation. Okay, so that's the first step. So let's remove the denominator. So this will be y times x minus 3 equals to 2x plus 1. Then you get xy minus 3 minus 3y equals to 2x plus 1. And move all the x terms over to the other side. So xy minus 2x, and move this negative 3y term to the other side, then you would get 3y plus 1. Okay, now factorize out the x. So x times y minus 2 equals to 3y plus 1. Divide by y minus 2 on both sides, you get x equals to 3y plus 1 over y minus 2. And the final step would be to replace the x with f inverse x and all the y's with x. So f inverse x is 3x plus 1 over x minus 2. So yeah, this will be our final answer for the first part. Let's move on to the next part. Okay, so for the second part, we are told that fx, so the function in here is just a composite function, is basically just f bracket fx. Okay, so they told us that is equals to this this form. Okay, so we are told to find the possible values of all the coefficients p, q, r, and s. Okay, so first things first, let's remind ourselves of what a composite function is. So a composite function is basically a function inside of another function. So in this case, fx is inside of fx, okay? So what that looks like in practice is all the x's in fx, they're just replaced by fx again. So this just equals to 2fx plus 1 over fx minus 3. Okay? So that's what it means. And then with that, we can get started. Okay, so let's copy that definition down, like what I wrote on the top. So just 2fx plus 1 over fx minus 3. Okay, and let's deal with the numerator and the denominator separately. So let's find the numerator first. Okay, so 2fx, so fx is 2x plus 1 over x minus 3. 2x plus 1 over x minus 3 plus 1. So x minus 3, 2 times 2x plus 1. That's 4x plus 2 plus, so for 1, let's just convert it into a fraction, the same denominator. So it's just x minus 3 over x minus 3. So you add the fractions up together, keep the denominator the same. 4x plus 2 plus x minus 3. So 4x plus x, that's 5x. 2 minus 3, that is minus 1. So this is the numerator. And the denominator is just fx minus 3. So it's just 2x plus 1 over x minus 3 minus 3. Same process. Just make the denominator of 3 equals to x minus 3. So x minus 3 over 3 times x minus 3. So x minus 3, 2x plus 1 minus, simplify this by expanding it. So 3x minus 9. So minus 3x minus 9. So it becomes plus 9. Okay. Simplify everything. So 2x minus 3x, that's minus x. And 1 plus 9, that's 10. So minus x plus 10 over x minus 3. Okay. Right. So the top one is the numerator, the bottom one is the denominator. So fx is the numerator divided by the denominator. So dividing by the denominator is the same as multiplying by the flipped version of the denominator. So you just swap the numerator and the denominator for this one. Okay, so it's just x minus 3 over minus x plus 10. Okay, well, let me see if everything's correct. It seems like it is. Seems almost correct. Okay. Oh, wait. Oh my goodness. I just realized, yeah, I accidentally put the wrong sign. Yeah, the denominator here is supposed to be minus. So sorry about that silly mistake. Okay, yeah, so now it makes things like a lot easier. So yeah, these two will cancel out, and our final answer would be 5x minus 1 over minus x plus 10. Or if you want to express it in this exact form, in this exact order, it would be 5x minus 1 over 10 minus x. And hence P is going to be 5. Q is going to be -1. R is going to be 10. And S is going to be -1. So these are our final answers for this last part as well as the entire question. Let's move on to next question. Okay, so for this question, first part, we're told to prove this identity. Okay, so this is a very typical prove the identity question. You must know how to do this. So first things first, we can see that on the left-hand side, it's two separate fractions, but on the right-hand side, it's just one fraction, and it's in terms of cosine, okay? So our first step would be to combine the two fractions together into a single fraction. All right, so let's write down the two fractions. So 1 over 1 minus sine theta plus 1 over 1 plus sine theta. So to combine them, we need to make the denominators the same. So for the first one, you just multiply 1 minus sine theta with 1 plus sine theta for both the numerator and the denominator. So you also multiply the numerator. So 1 times 1 plus sine theta, which is just 1 plus sine theta. And then you add it with the other fraction. So 1 plus sine theta, you multiply it with 1 minus sine theta. And you also multiply it in the numerator. So 1 times 1 minus sine theta. So you'll get 1 minus sine theta in the numerator. So let's add these fractions up together, keep the numerator the same. So 1 plus sine theta plus 1 minus sine theta. 1 plus 1 is 2. Sine theta minus sine theta, yeah, that's just 0. And for the new denominator, you can see that it's in the form a minus b and times a plus b. And we know that this is basically just a difference of squares, which can be simplified to a squared minus b squared. Okay, so I can write it down as 1 squared, which is just 1 minus sine squared theta. Okay, so 1 minus sine squared theta. And this right here is actually in your MF19. Oh, sorry. It's in your MF19 under trig. So if you move the sine square over to the other side, you will see that cos square equals to 1 minus sine square theta. So we can replace 1 minus sine square theta with just cos square. So this is just 2 over cosine square theta. So yeah, we can write proven to conclude our answer for this question. Let's move on to the next part. Okay, so for this part, we are given the keyword hence. So that means we need to use the result from the previous part to solve this equation for this domain of theta between 0 degrees and 360 degrees. Okay, so first things first, let's try to see what is similar between this equation and our identity that we proved in the previous part. So on the left-hand side, they are very similar. The denominators are the exact same. The signs are the same. The only difference is that both of the numerators is 3 instead of 1. So to make it similar to that one, we can just factorize the 3 out from the left-hand side, okay? Since 3 is a common factor, so we factorize 3. So we get 1 over 1 minus sine theta 3 bracket 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals to 12. And to get rid of the 3, you can just divide both sides by 3. You would get 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals to 12 divided by 3, which is just 4. And this one, you can just replace it with 2 over cos square. So 2 over cos square theta is just equals to 4. Okay, and now we're going to multiply both sides by cos square theta. So you'll get 4 cos square theta equals to 2. And we'll isolate the cosine square theta. So cosine square theta is just 2 divided by 4, which is half. And to make it just cosine theta, take the square root on both sides. You're going to get 2 answers. So first you'll get positive square root 1 over 2. So that's just 1 over square root 2. And the second answer, you just get the negative version of that, which is minus 1 over square root 2. Okay, so now here comes the solving part, finding theta. Okay, so to find theta, we're gonna have to use the unit circle. Okay, so label your quadrants with the letters. So the first quadrant between 0 degrees and 90 degrees is A. Second one is S. Third one is T. And the last one is C. So the letters, they represent like for which trig functions are they like positive for. So the first quadrant, all the trig functions are positive. Second quadrant, S. So only sine is positive over there. And so on and so forth for T for tangent and C for cosine. Okay. So for us, our domain for theta is from 0 to 360 degrees inclusive. So it's basically the entire circle. Okay. Right. So with that, let's solve this one. Cosine theta equals to 1 over square root 2. So first things first, we can see that this one is positive. And for cosine, the first and the fourth quadrant are positive. So let's find the angle in the first quadrant first. So for the first quadrant, the angle is going to be an acute angle like this. Yeah. So to find any angle in the first quadrant, you just directly take the cosine inverse, okay? So theta is just cosine inverse of 1 over square root 2. And since our domain is given in degrees, you must express your answer in terms of degrees. So set your calculator to degree mode. Okay, we get a very perfect answer, which is 45 degrees. And now, let's find the angle in the fourth quadrant, since we said that cosine is positive for these two quadrants. So for the fourth quadrant, the theta is actually going to look like this. It's going to be a reflex angle more than 270 degrees and less than 360 degrees. So to find that, you just take 360 degrees minus the basic angle. So this is the basic angle, which we'll call alpha. It's basically just the angle in the first quadrant, cosine inverse 1 over square root 2. So it's just 360 degrees minus 45 degrees. So you'll get 315 for the first solution, cosine theta equals to negative 1 over square root 2. So these are our first two answers for theta. Now let's solve the second one. Okay, so as we can see here, this one is basically the same magnitude, except that it has a negative sign. So the quadrants for this second expression, yeah, they're in different quadrants. They're in this second and the third quadrant. Okay, so let's find for the second quadrant first. So for the second quadrant, theta is going to look roughly like this. So it's an obtuse angle. It's more than 90 degrees and less than 180 degrees. Okay, so to find that, you just subtract 180 degrees from the basic angle. So it looks something like this, the basic angle. Okay, so you subtract it. So 180 minus 45, you get 135 degrees. Okay, and for the final one, we find the angle, the theta in the third quadrant. So for visualization purposes, that value of theta actually looks like this. It's a reflex angle that is more than 180 degrees, but less than 270 degrees. And to find it, you just add 180 degrees plus the basic angle, alpha. So the basic angle for this is from here to here. Okay, so this one is just 180 degrees plus 45. So that is going to get you 225 degrees. And these four values of theta are our final answers for this question and this equation. Let's move on to the next question. Okay, so for this question, we are told that the equation of a circle is as such. And for the first part, we're told to state the center and the radius of the circle. Okay, so this is a very basic question. You must know how to do this. So to know how to do this, you need to know the general form of the equation of a circle. So it's just x minus a squared plus y minus b squared equals to r squared. So a is the x coordinate of the center, b is the y coordinate of the center, and r is the radius of the circle. So we can see that our equation here, it follows this exact template in here, except that there's like no a inside the x, and then there's no b next to the y. It's just x squared plus y squared. So that means that both a and b, they're equal to 0. So we can therefore say that the center is just 0, 0. And for the radius, that's given right here on the right-hand side, r squared. So r squared is 45 over 4. So to find the radius, you just take the square root of that, and you would get 3 over 2 square root 5. Yeah, so this 2 would be our final answers for this first part. Let's move on to the next part. Okay, so for this part, we are told that the line x plus y equals to 3 over 2 intersects the circle at points A and B. So this line intersects the circle at 2 different points, and we are told to find the exact distance AB. So the keyword here is exact. So no rounding it off to 3SF or whatever. You have to leave it in this form, like just this the same form as the radius in the previous part. Okay. All right. So for these types of questions, even though this is, I would say, a very simple question, it's always good to have like a rough sketch of what you're dealing with. So this is the circle, And the line, I would say, is something like this. Because if you make y the subject, you'll get y equals to 3/2 minus x. And the coefficient of x is negative, so it's definitely downward sloping. Yeah, so this is the rough sketch, and these 2 points are points A and B. And we're told to find the length of this line AB. Okay, so yeah, let's find the coordinates of these 2 points first. Then we're going to use the distance formula to find the distance. Okay, all right, so let's start. So x plus y equals to 3/2. Let's make y the subject. So y equals to 3/2 minus x. So this is the first one. And then the equation of the circle is just x squared plus y squared equals to 45/4. Yeah. So this equation 2. And we're going to substitute the first equation into the second equation. Okay, so x squared plus y squared, so y is 3/2 minus x squared equals to 45/4. So to expand this, you just use the a minus b squared formula. So you get a squared minus 2ab plus b squared identity. So a squared is 3/2 squared, that is 9/4 minus 2 times a, 3/2, b is x, plus x squared equals to 45/4. And then you get x squared plus x squared, that's 2x squared, minus 2 times 3/2, that is minus 3x, plus 9/4. And then you also move this 45/4 to the other side because it's a quadratic equation. Yeah, equals to 0. So to make things easier, let's just multiply both sides of the equation by 4 to get rid of the fraction. Okay, so you get 8x squared minus 12x plus 9 minus 45. 9 minus 45 is minus 36 equals to 0. So this is our final quadratic equation. And if we solve for x, we're just going to get the x coordinates of a and b. So let's try to factorize. Okay, so factorizing gives us x minus 3 and 8x. Wait. Oh, wait, I just realized. Oh, wait, these are all even. You're supposed, you can factorize the 2 out from, wait, no, you can factor out 4 from one of them. Yeah, so you factorize, oh my goodness. So you factorize 4. And yeah, you factorize out 4. Yeah, then you get 4 times x minus 3 times, oh my goodness, times 2x plus 3 equals to 0. And now you just equate all the factors to 0. Oh my goodness, I'm already running out of space. Okay, I'm just gonna straight away just write down the x values. So x is equals to 3 and x is equals to negative 3/2. And I'm also just gonna straight away write down the y values. So y is just 3/2 minus x. So it's 3/2 minus 3. So that is 1.5 minus 3 minus 3/2. And this is y equals to 3 over 2 minus negative 3 over 2. So 1.5 minus negative 1.5 is just 3. Yeah, so these are the coordinates for points A and B, respectively. And to find the distance of AB, so distance, you're gonna have to use your distance formula from like before A levels. So distance formula is something like this, something like x1 minus x2 squared plus y1 minus y2 squared. So one way to remember is that it's almost the same as the um, gradient formula. Like you find the difference between the respective x and y coordinates, but instead of dividing, you square them and add them up, and you square root them, just like a Pythagoras theorem. Okay, so let's use that. So x1 is going to be 3 minus x2, which is negative 3 over 2 squared plus y1, that is negative 3 over 2. Remember, x1 and y1, they have to be corresponding to each other. Okay, minus y2, which is 3. Okay, now you just type it into your calculator. You'll get 9 over 2 square root 2 units as your final answer. Yep, so this would be all for this entire question. Let's move on to the next question. Okay, so for this question, we are given the equation of the curve C such that dy dx is equals to this. So we're given the dy dx version of the equation, and we're also told that the curve passes through the point 4, 7. So for the first part, we need to find y in terms of x, or basically find the equation of the curve from the dy dx. So we need to integrate it. Okay, so first things first, we can see that the expression that they gave us for dy dx is a really weird expression. Like we usually don't integrate this, so we're gonna first make it into a form that we're like actually more familiar with, aka a polynomial. So we're gonna simplify it. Okay, so x minus 3 squared over square x, I'm gonna rename it to x to the power of half. So for the numerator, we're gonna expand it fully. So using a minus b squared, you get a squared, which is x squared, minus 2ab, so 2x times 3, that is 6x, plus b squared, which is 3 squared, so 9, over x to the power of half. So now to simplify it into a single polynomial, we're going to split it up into like different fractions. So we're going to use like this property. So a plus b over c. It's just a over c plus b over c. Okay, so this is just going to be x squared over x to the power of half minus 6x over x to the power of half plus 9 over x to the power of half. So dy dx just going to be x squared over x to the power of half. So using the laws of indices, you just minus the powers. Since you're dividing, you would get x to the power of 3 over 2 for the first term, and then the next term is 6 times divided by x to the power of half. So that's just minus 6 x to the power of half. And then for this one, you just make the power into a negative power using 1 over x to the power of n equals to x to the power of negative n. So hence the last one, 9 over x to the power of half, is just going to be 9 x to the power of negative half. So this is our simplified dy dx term. Now we are ready to find y by integrating. Okay, so to find y, just integrate this whole expression in terms of with respect to x. So just like what we did with integration for differentiating, you integrate each term separately and keep the sign, okay? So integrating x to the power of 3 over 2, instead of minusing the power, you add 1 to the power. So 3 over 2 plus 1, that is 5 over 2. And you divide by the new power, 5 over 2. Keep the minus sign and integrate this term. So any constants that are not in terms of x, like 6, you can leave them alone and just integrate x to the power of half. So integrating that, you would get half plus 1, that is 3 over 2, and you divide by 3 over 2. Plus, this is also the same. Keep the 9 and just integrate x to the power of negative half. So integrating that, you'll get x to the power of half divided by half. And for integration, you must always put plus c. Okay? For integration, it's a must. Okay, let's simplify this. So 2 over 5 times x to the power of 5 over 2 minus 6 times 2 over 3. 6 divided, yeah. So that's 4. So minus 4x to the power of 3 over 2 plus 9 divided by half. That's 18. X to the power of half plus c. So that's y in terms of x. But you still have to solve for the unknown constant c. And that's where the second piece of information is relevant. So we're just going to substitute the coordinates. So we're going to substitute x equals to 4 and y equals to 7 because the curve passes through those points. Okay, so 2 over 5 times x times 4 to the power of 5 over 2 minus 4 times 4, 3 over 2 plus 18 times 4 to the power of half plus c is equals to 7. We'll just type all of these into your calculator. Okay, give me a while. Okay, so you get 84 over 5 plus c equals to 7. And making c the subject, you would get 7 minus 84 over 5 minus 49 over 5. Okay, so therefore the final answer is just going to be 2 over 5 x to the power of 5 over 2 minus 4 times x to the power of 3 over 2 plus 18 times x to the power of half minus 49 over 5. So yeah, this would be all for the first part. Let's move on to the final part. Okay, so for this final part, we are told that the equation of a different curve D is also the same, such that the dy dx is exactly the same as C, but the only difference is that it passes through the point 4, k. So you can see that the x coordinate is the same. The only difference is the y coordinate. Okay. So we are supposed to describe in terms of k the transformation that maps curve C onto curve D. So the keyword here is describe. So you're not like supposed to like write the like you're supposed to write it fully in words. Like you're not just supposed to give the numbers, okay? All right, so let's go through the thinking process for this question. What should your thinking process be like? So here, since the dy dx term is the exact same, the indefinite integral is going to be the exact same. It's going to be exactly this. However, when like we're going to find our unknown constant c, we're going to get a different value for c. Yeah, so we're going to substitute x equals to 4 and y equals to k instead, okay? So this entire side would be the same, only this side, instead of 7, we'll get k, and therefore our c for d is going to be k minus 84 over 5, okay? And therefore y is going to be this whole thing. I'm going to call it cx, okay? Cx plus k minus 845. All right. Yeah. So this is for the curve D x. Okay, let me just write this fx. And for cx, we know it's this whole thing minus 49 over 5. I mean fx minus 49 over 5. Okay, so now I'm gonna like tell you the algebraic effect on the like this type of transformation. So let's say you have a function y equals to fx. So when you add like a value, let's say like d, you actually shift it vertically upwards by d units or through vector 0, comma d. So again, this is a reference to the previous translation question where we had to find the equation of the curve after those translations were applied. Yeah, so this is the translation that happens when you add a function by a constant such as d. It gets shifted up by d units or through the vector 0, comma d. So now for this, so I hope you can see that the only difference between cx and dx is by how much they're added, by 2fx. Okay, so to find the d value, so it says to transform c onto d, we're going to take the constant of c, so minus 49 over 5. Wait, no, we're going to take the constant of d and subtract it with the constant of c. So k minus 84 over 5 minus negative 49 over 5. So you just get 49 over 5 minus 84 over 5. Yeah. So you just get k minus 7 as your d value. So therefore, dx is literally just cx plus k minus 7. So therefore, we can say that shift curve C upwards okay, actually the proper term is translate curve C through the vector 0, k minus 7. Yeah, for like the y component of the vector, it's not the opposite, it's the exact same. Only for the x component is the opposite. Okay? And yeah, this would be all for this entire question. Let's move on to the next question. Okay, so for this question, for the first part, we are told to completely expand this expression right here. Okay, so to expand this, you can go to your MF 19 and since our expression inside the bracket has two terms, we can use the binomial series. So we're going to use the first formula in here, where the power n is a positive integer. In our case, it's 4. So as you can see, to get the expansion of this, the first term is always a to the power of n, and then it is n choose 1 times a to the power of n minus 1 times b. And then the next one is n choose 2 times a to the power of n minus 2 times b squared. So, so basically what happens is the power of a decreases by 1 for every subsequent term, while the power of b increases by 1 starting from the second term. Yeah, and the power of b is what goes in here. So n choose 2, b squared, n choose 3, b cubed. Okay, so that's the general like formula generalized. Okay. All right. So let's get started with our expansion. My goodness. Okay, so a to the power of n. So a is 3 and n is 4. So it's 3 to the power of 4 plus my goodness, plus n is 4. Choose 1 times 3 to the power of 4 minus 1, 3 minus 2x plus goodness, plus 4 choose 2. My goodness, what's going on? 4 choose 2 times 3. Okay, let me pause the recording for a while. Okay, sorry for the delay. So let's continue. So this is 3 squared times minus 2x squared plus 4 choose 3 times 3 to the power of 1. Oh my God. minus 2x minus 2x to the power of 3, and the final term is minus 2x to the power of 4. So let's simplify this. So 3 to the power of 4 is 81 plus 4 choose 1 times 3 to the power of 3 times negative 2, that is minus 216. So minus 216x. And 4 choose 2 times 3 squared, that's 54. That's 54. I don't know what's, I'm sorry. 54 minus 2x squared. So minus 2x squared, that's just 4x squared. X squared. And 4 choose 3 times 3, that is 12. And minus 2 whole thing cubed, that is minus 2 cubed, that is 8. And x cubed. And plus negative 2x to the power of 4. So it's negative 2 to the power of 4 times x to the power of 4. So it's just plus 16 to the power times x to the power of 4. Yeah. So completely simplifying, you get 81 minus 216x plus 54 times 4. So plus 216x square minus 96x cubed plus 16x to the power of 4. So this would be our final answer for the first part. Let's move on to the next part. Okay, so for the second part, we are told to use our answer to the previous part to find this expression, and we're told to give an answer in this form: p plus q square root 2, where p and q are integers. Okay, so first things first, let's try to notice the similarities between this expression and part A. So you can see that everything is the same except the square root 2 part. So basically, the x is replaced by square root 2. So to find this, we're just going to substitute x equals to square root 2. So let's do that. Okay, so it's sub x equals square root 2. So you get 81 minus 216 times square root 2 plus 216 x squared. So square root 2 squared minus 96 x cubed. So 96 square root 2 cubed plus 16 square root 2 to the power of 4. So simplifying, you would get, oh my goodness, you would get 81 minus 216 square root 2 plus 216 times square root 2 squared. So that's just 216 times 2, which is plus 432 minus 96. 96 square root 2 cubed, that is 2 square root 2 square root 2 plus 16 times square root 2 to the power of 4. That is 64. Okay, now for all the whole numbers, 81 plus 432 plus 64 is 577. And the square root 2 terms is 216 minus 96 times 2. So you get minus 408 square root 2. And yeah, this fits our template here exactly. So we can leave this as our final answer. And if you want to check whether you're correct, you just type this into your calculator and see if you get the same answer as you obtain in here. So yeah, with that, let's move on to the next question. Okay, so for this question, we're basically just told to solve this equation that's given here. Okay, so first things first, let's open up the brackets in the middle term here. So this is going to be x to the power of 2 over 3 plus, so since like the power is completely outside the brackets, you can actually like split the powers. So this is just going to be 8 to the power of 1/3 times x to the power of 1/3 equals to 24. And simplifying, you will get x to the power of 2/3 plus 2 times x to the power of 1/3 equals to 24. Okay, so now the question is, how do we solve this equation? Well, let's try to manipulate it into some sort of quadratic. So to do that, just look for a term where you can factor out like a 2 from, and if you factor it out, the power would be the same as the power of the other terms. So in this case, we actually we can make this term into just x to the power of 1 over 3 to the power of 2. So I'm using this law of indices. So a to the power of b to the power of c. You can actually just split it to make it a to the power of b bracket to the power of c. Yeah, so this is the technique I'm using. So then plus 2 times x to the power of 1/3. And then this constant term, you can move it over to the left-hand side to make the right-hand side equals to 0. Yeah, so now we're just going to substitute u equals to x to the power of 1/3. And we have gotten ourselves a quadratic in terms of u. Okay, so now let's try to factorize this quadratic equation. So factorizing it, we get u minus 4 times u plus 6 equals to 0. So solving it, you get u minus 4 equals 0, u equals to 4, and u plus 6 equals to 0, u equals to minus 6. And now, but you need to remember we're solving for x, not for u. So we're going to substitute back the x terms. So you get x to the power of 1/3 equals to 4, and x to the power of 1/3 equals to negative 6. So just to just seeing if like both of them are valid. Yes, they are. There's no like restriction on whether x to the power of 1/3 can be negative or positive. All right. So to get just x, we're gonna apply the power of 3 to both sides. So this is just x equals to 4 to the power of 3. So x equals 64. And this one is x equals to negative 6 to the power of 3. So that's minus 216. Okay. And yeah, I believe this would be a final answer, or final solutions for this equation. If you want to double check, make sure that everything is right, just substitute these numbers back into the equation above and see if you get 24. And with that, we're going to move on to the next question. Okay, so for this question, we are told that the 7th term of an arithmetic progression is 77. The sum of the first n terms of the progression is denoted by Sn, and we're told that S11, the sum of the first 11 terms is 880. Okay, so for the first part, we're told to find the 20th term of the progression. Okay, so for an arithmetic progression, to find the general term, uh, the term, yeah, like to find the general term, it's actually given by this formula here. So u to the u subscript n is equals to a plus n minus 1 times d. Okay, so n is like the nth term. So in this case, is u 7th is equals to a. So a is the first term, we don't know that, plus n minus 1. So 7 minus 1, that's 6 times d. Okay, so a plus 6d equals to 77. So this is the first equation. Now the second equation we're going to get from the second piece of info is that S subscript 11 is 880. The sum of the first 11 terms is 880. So to find the sum of the first n terms, the formula is given here, Sn. We're given two formulas. One is this, but it's not very useful because it requires you to know the last term, which we don't. So we're going to be using the more complicated second formula, which is half n square curly bracket 2a plus n minus 1 times d curly bracket. Okay, so this is S11 equals to half n. So n is 11. And then curly bracket 2a plus n minus 1. So 11 minus 1 is 10. And then d curly bracket. Okay, so this is 11 over 2. 2a plus 10 d equals to 880. Okay, so we can factor out 2 from this bracket. So this was going to give us 11 times A plus 5D equals to 880. And since we have 11 on both sides, we can just divide both sides of the equation by 11 to get A plus 5D equals to 80. Yeah. So this is our equation 2. Okay. So with these two equations, we can find our A value, the first term, and our D value, the common difference. Okay, so we can see that for both equations 1 and 2, we have A as the common term. So we can remove that by subtracting equations 1 and 2. Okay, so equation 1 is A plus 6D minus equation 2, A plus 5D equals to 77 minus 80. So A minus A, that's just 0, and 6 minus 5D, that's just D. So for D, we just get minus 3. Okay, so this is our D value. Now we're gonna try to find A. So A is just 77. We are using the first equation, 77 minus 6D. So 77 minus 6 times negative 3. Okay, so this is 77 plus 18, 95. Yeah, so these are our values for D and A. Now we can find the 20th term of the progression by using the general term formula, which we used in our very first step. Okay, so we're going to find U20 is equals to, again, A plus n minus 1 times D. So A is 95 plus n minus 1. So n is 20, then minus 1, that's 19, times D, which is negative 3. Okay, so 95 plus 19 times negative 3. You would get 38 as your final answer. So yeah, 38 is our final answer for the first part. Let's move on to the next part. Okay, so for this question, we're told to find the smallest number of terms n such that the summation of the first n terms is less than 50. Okay, so for this, we're going to use this formula here in our MF19, this one again. So half n curly bracket 2a plus n minus 1d curly bracket. All right, so half times big N curly bracket 2a. So we already found a in the previous part, which is 95 plus big N minus 1 times d, which is negative 3. Less than 50. Okay, so this is n 2 times 95, so 190 n minus 1 times negative 3. So this is negative 3n plus 3 less than, so as you can see, I didn't write the half because we actually like multiply by 2 on both sides. So 50 times 2, that's going to be 100. Okay. And simplify and expand everything now. So 190 plus 3, 193, minus 3n less than 100. Now expanding, you get 193n minus 3n squared less than 100. Then you get minus 3n squared plus 193 and minus 100 less than 0. Okay, so for me personally, I don't like it when the coefficient of my n squared term is like a negative number. So I'm gonna try to remove it by multiplying or dividing both sides by a negative number. So, okay, I'm just gonna divide both sides by -1. So with that, we will get 3n squared minus 193n plus 100. And one thing to keep in mind is when you divide or multiply by a negative number, the inequality sign flips. So this is going to be more than 0. Okay? All right, so now let's try factorizing it. So 3n squared minus 193 plus 100. Okay. Well, unfortunately, it doesn't factorize nicely. So yeah, we're gonna have to solve it manually. Okay. So I'm just gonna equate it to 0. 3n squared minus 193n plus 100 equals to 0. So just use a quadratic formula. So n is minus b, so which is minus negative 193. So just 193 plus minus square root of b squared, which is negative 193 squared, minus 4 times a. So a is 3. And then c, which is 100, over 2 times a, which is 3. So this gives us critical values of 3 minus 193, 100. So I'm just going to round it off to 3 SF. So 63.8. So these are critical values, not our final answers. And 0.5, my goodness, 522. Okay. All right. So sketch the graph of this. So since like this expression right here, the coefficient of n squared is positive, it will be a smiley shape. And the critical points would be these 2 points right here. So the 63.8 is going to be here. And 0.522 is going to be here. And since it is more than 0, we're going to look at the region above this line. So that basically includes everything to the left of this point and everything to the right of the bigger point, okay? So therefore, our final answer for this quadratic inequality is n is less than 0.522. 2 and n is more than 63.8. Okay, so for one of the solutions, we know it cannot be possible. Like one of the solutions is invalid. Okay, so we're gonna reject this one. We know that n cannot be less than 1, let alone a rational number. So this is rejected. So this is the only correct inequality. And using this inequality, we can find the smallest number of terms. Okay. So the smallest number is basically the nearest whole number to 63.8, like which is more than 63.8, which is n equals to 64. And n must be a whole number at all times. So yeah, this would be a final answer for this part as well as the entire question. Let's move on to the final question. Okay, so for this question, we had shown a diagram which shows the curve with this cubic equation and a straight line. And we also told that the straight line, it passes through the two stationary points on the curve. And for the first part, we are told to show that the equation of the straight line is as such. Okay, so to find the equation of the straight line, so we're told that this straight line, it passes through the two stationary points of the curve. So obviously we need to know the coordinates of these two stationary points right here. Okay, so to find those, if you see the word stationary points, you should automatically think of dy dx equals to 0. So let's find dy dx first. So dy dx is equals to d dx of this entire curve, of this entire equation, minus x cubed plus 9x squared minus 15x minus 3. So again, to differentiate it, you just differentiate each term separately and keep the signs in between them. Okay, so differentiate first minus x cubed. So you bring down the current power, which is 3. So it's minus 3x. And then you minus 1 from the current power, then you get 2. So it's minus 3x squared. And you keep the plus sign, do the same for this. You bring the power down, the current power down. So you get 9 times 2, which is 18. And then you minus 1 from the current power, which is 2. So you get 18 times x to the power of 1. Same for this. So you keep the constant term 15 and you only differentiate the x. So you differentiate x, you bring down the current power, which is 1. So 15 times 1 is 15. And then you minus 1 from the current power, so you get 0. So x to the power of 0, that's just 1. So basically the x just goes away. And then for the constant term, the derivative is just 0, so you just leave it alone, okay? So this is our final expression for dy dx. Now we're going to equate it to 0 and solve for x. Okay, so we're going to, so I realized that all the coefficients are actually multiples of 3. So I'm gonna divide this both sides of the equation by -3. So you will get x squared minus 6x plus 5 equals to 0. Okay, so let's try factorizing this equation. So you're gonna get x minus 5 times x minus 1 equals to 0. Okay, so you're gonna get x. So just equate each factor to 0. So you get x equals to 5 and x minus 1 equals to 0. You will get x is equals to 1. So these are the two x coordinates of the two stationary points. But however, we need the full coordinates, so we're going to find the y coordinates as well, which you can do by just substituting these x values into the original equation. So this is y is minus x cubed, so minus 5 cubed plus 9x squared, so plus 9, 5 squared minus 15x, so minus 15 times 5 minus 3. And using this, you get minus 5 cubed plus 9 times 5 squared minus 15 times 5 minus 3. You will get 22. Okay. And then for the second one, you'll get y is equals to minus 1 cubed plus 9 times 1 square minus 15 times 1 minus 3 equals to minus 1 cubed plus 1 times 9 times 1 square minus 15 times 1 minus 3. You would get minus 10. Okay, so therefore we have found the coordinates of the stationary points, which is 5, 22, and 1, negative 10. Okay. All right, so now that we know the full coordinates of these two stationary points, now we can find the gradient of the line by using the gradient formula. Okay, so m is y2 minus y1. So y2, I'm going to use 22, and then minus y1. y1 is the other one, which is negative 10. So 22 minus negative 10 over x2. So x2 is just 5. So 5 minus x1, that's 1. Okay, so you will get 32 divided by 4, which is 8. So the gradient of the line is 8. Okay, and now we're going to just add it into the general form of equation of a straight line, which is your y equals to mx plus c. So this is just going to be y equals to 8x plus c. And to find the c, we're just going to substitute either one of the coordinates into the equation. So I'm going to substitute this one. So y is negative 10 and x is 1, and then c is just c. So c is just going to be negative 10 minus 8 equals to negative 18. Okay, so these two will give us our final equation, y equals to 8x minus 18, which is the exact result that we are required to get. So we can stop here and write shown. Yeah, and write shown. Yeah, so with that, let's head on to the next question, next part. Okay, so for the second part, it's just 1 mark. We just have to verify, so like double check that that curve also meets a straight line when x is equals to 3. Okay, so I guess we basically have to find the y values of both of them when x equals to 3. So sub x equals to 3 into y equals to 8x minus 18. So you get y equals to 8 times 3 minus 18. So you get 24 minus 18. So you get 6. And then you do the same for the cubic term, minus x cubed. So minus 3 cubed plus 9x squared plus 9 3 square, 9 times 3 square, minus 15 times 3 plus minus 3, and yeah, minus 3. So you just type it into a calculator. Yeah, so you also get 6. Therefore, you can say since since same y value, the curve meets when x equals to 3. Verified. Yeah, so yeah, with this we can head on to the last and final part. All right, so for this part, we're told that the shaded region is bounded by the by the curve and the straight line, and we are told to find the area of the shaded region. So let's go back to our diagram and see what they're actually talking about. Yeah, so this is the shaded region. So it's basically, so to find the area of that is basically the area under the curve. So between this point and this stationary point. So I believe this point is the point where x is equals to 3 and y is equals to 6, as we found out just now. And this point is the stationary point where x is 5. Yeah, 5. And y is equals to 22. So it's basically the area under the curve between 3 and 5 and the area of this trapezium that I'm shading in blue, okay? So let's find the area under the graph from x equals to 3 to x equals to 5 first. Okay, so to find that, you just take the definite integral of the equation of the curve. So it's minus x cubed plus 9x squared minus 15x minus 3 dx, and then plug in your lower and upper limit. So in our case, it's 3 and 5. So 3 is the lower limit, 5 is the upper limit. Okay. And now you just integrate it with respect to x. So integrating is just the opposite of differentiating. So to integrate minus x cubed, you keep the minus sign, add 1 to the power, so it becomes x to the power 4. And then you divide it by 4 plus keep the 9, integrate x squared, you get x to the power of 3, you add 1, and then you divide by 3, and then you minus 15 over 2 x squared. So again, what I'm doing, I'm just adding 1 to the present power, which is, then you get 2, then you divide by the new power, which is 2. So you get 15 over 2. And then for any constant terms, so you integrate 3, you just add an x to it. And then just put your lower and upper limits on the right-hand side, and you just substitute it 1 by 1. So you substitute the 5 first, so you get minus 5 to the power of 4 over 4 plus 9 over 3, that is just 3, yeah. So it's just 3x cubed. So 3 times 5 to the 5 cubed minus 15 over 2, 5 squared minus 3 times 5, and then minus the same thing but for 3, so minus 3 to the power 4 over 4 plus 3 to the power of 3 cubed minus 15 over 2 3 squared minus 3 times 3. Okay, so just put it into your calculator directly. Minus 15 over 2, 5 squared. 15 over 2, 5 square, minus 3 over 5. Okay, and then minus negative 3 to the power 4 over 4 plus 3 times 3 cubed minus 15 over 2, 3 squared minus 3 times 3. Okay, yeah, so for the area below the curve, under the curve, you get 32 units. My goodness. Yeah, so we're done with that. And now we're going to need to find the area of the trapezium, which is basically the area below the straight line from 3 to 5, okay? So there's two ways you can do this. Either you just integrate the equation of the straight line and you plug in the limits 5 and 3, or you can find the area of the trapezium, which is what I'm going to do. Okay, so to find the area of the trapezium, you just take half times the sum of the parallel sides. So in this case is this and this side, and you times by the height, which is basically this length. Okay, yeah, so let's start. Okay, so area, goodness, area under line. It's just half times the sum of the parallel sides. So the longer one is 22 units, shorter one is 6 units. So 22, my goodness, 22 plus 6. And then the height is just between 3 and 5. So that's gives us a height of 2. Okay, so half times 22 plus 6 times 2. So that gives us, here, let's put the units at 28 units squared. Yeah. And finally, we can find the area of the shaded region. Okay, so shaded region is the area under the curve, which we found in our first step, so 32, minus the area under the line or the trapezium, which is 28. And that gives us a total area of 4 units squared for the shaded region. Okay, so this would be our final answer for this part, as well as the entire question. And we have also come to the end of this paper. So again, sorry for not uploading for such a long time. I had some personal commitments, but now I'll be back to uploading consistently. So stay tuned for more past paper solving videos and possibly even topical videos of A-level maths and further maths, where I would be covering like the different types of questions and like how to deal with them. So stay tuned for that. And if you have any like questions or doubts or anything that you would like to point out, feel free to use the comment section down below, and I will see you guys again next time. Okay, thank you guys. Bye bye.